Okay, for today we are going to be talking about geometric mean and how this shows up on similar right triangles. So first of all, before we get too far into it, what do you guys think it means for something to have a geometric mean? Okay, so someone said that it's maybe the average of something dealing with a triangle potentially. So let's kind of elaborate on that a little bit. So mean, you guys have probably heard that word before. Maybe if you've ever had to deal with like a little bit of statistics, real basic statistics like mean, median, and mode, like those kinds of things. And mean is another way of saying average. So finding like the average test score, average points per game, something like that. Okay. When we think about it as geometric mean, and maybe using what we've been talking about the last couple of days with triangles, we are going to be figuring out what the mean, the average between similar triangles would be. Okay. So I'm going to write down a definition here. Geometric mean comes from a proportion where a value is used twice. Okay, for example, we're still setting up proportions with these, but when I set mine up, it might look something like this. That X shows up twice, okay? And so when we're setting up proportions and we're looking at similar triangles, we're going to be dealing with keeping matching sides together, but sometimes a side might be represented by the same amount. Or it might not look exactly the same on your triangles, but they might be referring to the same segment, okay, or similar segments. And so we can set up our geometric mean, kind of like a proportion like this here. And to solve it, we would just continue to use cross multiplication. Okay, so we've been dealing with that before. So we would cross multiply, all right, and then we'll have to solve for our variable. So let's just do a couple examples where we're just given some numbers. We want to find the geometric mean of them. So the first one is I want to find the geometric mean of 2 and 8. So using kind of what I wrote up here as a model, 2 and the 8 would be replacing like my 3 and my 12. So I would do 2 over x equals x over 8, like that. And then we would cross multiply, and I would get x squared equals 16. Now, how do we get rid of a squared? You square root it, right? So we square root both sides. What is the square root of 16? Good, 4. So we would say x equals 4. So think about those similar triangles that we've been dealing with and like setting up proportions to solve for missing sides. We're doing similar things here, but what we're missing is that quantity that maybe keeps the ratios equivalent to each other in our two proportions that we're trying to set up. All right, so how would you guys set up the next one if you're working with 5 and 15? Right, you'd have 5 over x equals x over 15. Good. And then what would you guys do? Good, you'd cross multiply. So what is 5 times 15? Yeah, 75. Now, when you go to square root this, can we square root 75 perfectly? No, right? We get like a weird decimal if we try to do that. So think about what we talked about in the last section when we were simplifying the radicals. We need to simplify 75. So what's the biggest perfect square that goes into 75? Good, 25. 25 times what is 75? Yeah, 25 times 3. Okay, so you can see I'm splitting that 75 apart. And then I would say x equals, what's the square root of 25? Good, 5. And then what happens to the square root of 3? Yeah, it just stays. Good. So this would be your final answer. Okay, so now you kind of have an idea of how this geometric mean is going to work. We're going to do similar things here, but now what they're going to do is start throwing them onto right triangles. But these right triangles are going to be similar, okay? Remember, right triangles means that it has a 90-degree angle somewhere in the picture. And so you're going to see pictures that overlap. Like there's actually several different triangles inside this one picture here. And anytime that we do these, it's really confusing at times to look at a picture that overlaps like that much does. Okay. So it's easier for students to think about separating out the three triangles that are in the picture. You have two smaller ones that are kind of like next to each other inside the bigger one. So you can kind of see what they did out here is they drew out small, medium, and large, and they all look like each other because they're all right triangles. So remember, you would have a right angle in all of these triangles. So I'm just going to go ahead and put a little box in all of them. And then what we're going to do is looking at the three triangles here, we're going to pull out the letters. Like right now there's no numbers here, but I want to be able to pull out the letters so that I can figure out what sides would maybe go with what if I had to set up a proportion. So if you look at the small triangle, what sides do you know? So I just want to maybe think about if you had a right triangle here, remember we call the side across from the right angle, that has a fancy name. Do you guys remember what that name is for that side? It's called a hypotenuse, right? So on this small triangle, like A, B to D, that small little triangle kind of on the left side, the hypotenuse is where my A is. What would you guys say is the bottom of this small triangle? Good. X, and then the tall side would be Y. Very good. Okay. Now think the same way about kind of the middle sized triangle. So that's like this one here. I'm going to go over it in red. This is your middle sized triangle. Now think about where the right angle is there. It's right here. So what would be the hypotenuse? Good. The B. What's the smaller of the two sides? Good. The Y. And then what's that side length like D to C? Yeah, they have it as a Z. Okay. Now we're going to do the same thing, but for the big triangle in the picture. So like A up to B and then all the way down there to C. We're talking about like the whole entire thing. Again, keep track of over here now is where my right angle would be. So what's your hypotenuse? Good, it's the C. What would be the shorter leg? A, and then this other side would be, good, B. Okay, so now you can kind of see like we took those three triangles, we looked at those letters, we're trying to figure out what sides they should go on. The reason why we do this first is because we're looking for a proportion to set up. We're looking for like letters that we could put together. And there's lots that you guys could set up here. But one example, if I wanted to set up a proportion, is I see that like a Y and an X from that small triangle could go with Z and the Y from the medium triangle. So if I do Y over X, I would set that equal to Z over Y. Why do you guys think I set it up like that though? Like why did I choose those specific letters? Anyone see why I did that? Yeah, I have that Y quantity showing up two times, right? And like up above when we were doing our geometric mean with just numbers, we had like X and X on both sides, right? So we want to make sure that we're trying to find like letters that go together. Okay, now that's not the only situation that maybe that works. Like I could have done the B here and the Z here, and I could have done the C from the big triangle and the B from the big triangle. I could have put B over Z from the medium triangle and then C over B from the big triangle. See how B is repeated there? I could have maybe also figured out a way to do it with the A's. So if I use like my A here and my X from the small triangle, I could use my A and my C from the big triangle. So A over X would be equal to C over A. Again, that time my A's repeat. So there's different ways you can set up these proportions. It just depends on maybe what's the most useful for you with what you're trying to find. But the first step that I would suggest you do when you're using geometric mean is figure out what those three triangles should look like. You want them all to be labeled with as much information as you can. And then you pick a couple triangles that you can relate to each other and try to figure out what sides you maybe want to match up in your proportions so that you can solve for the missing variables. Okay, so let's do some examples here. starting with this first one. And again, I'm going to sketch out my triangle. So we're going to do 3 of them. We're going to do a small one, a medium-sized one, and a big one. Okay, they all should be right triangles, so you can put little right angle boxes in all of them here. And then we want to start labeling with what we have up above from our picture. So starting with the small triangle, remember this is where your right angle would be. Let's label our sides. So we see that the bottom piece is a 4, and then the other leg on the other side of that right angle is where the Y is. Okay, what can we label on the medium-sized triangle? Good, you know the bottom is Y, and you know that that tall side next to the right angle is 9. And then how about the overall big triangle? What do you know? How'd you get 13 for the hypotenuse? Yeah, you add 4 plus 9. We know it's the hypotenuse because it's across from that right angle, so that's going to be that side there. Okay, now think about your proportion that you want to set up, and think about the sides that are corresponding. So you can't just pick any sides that you want. You can't just grab whatever numbers you want at just random. You have to think about how are these relating to each other. So give me an idea of what you think we could do here. Good, I like what I heard there. So someone said put Y over the 4 and put the 9 over the Y, because these are both like the shorter and the longer legs of your triangle, not the hypotenuse. We can't really use that 13 for anything because the other 2 triangles don't have the hypotenuse length, and I don't really have any way of solving for them. So I like using the Y and the 4 and the 9 and the Y because those come from corresponding parts. Okay, I'm going to go ahead and cross multiply here. So we get Y squared equals 36. What would you guys get for Y? Good, just 6. Great job. Okay, let's do the next one. It's going to be similar to this, but they're going to maybe make it a little bit more challenging here for us. So the first thing is let's draw out our 3 triangles, our small one, medium-sized one, and our big one. Okay, go ahead and take a minute and try to label what you can. Okay, I've got labeled what I could see pretty clearly as far as like numbers and letters, but look at this middle triangle. Was there anything you guys could put on the middle one? I mean, there's no like clear numbers on any of those 3 sides, right? Could you maybe have used the 10 and the X to represent kind of the longer of the 2 sides, not the hypotenuse, but like the longer of the 2 by the right angle? If you know the whole thing's 10 and you know that this kind of left half with the little triangle is X, how could we maybe write something over here? Yeah, we could do 10 minus X. That may not be helpful for us, but it's good to at least maybe see that in case in a situation where I had to use that side, I needed to try to figure out a way to write that. Okay, so if you have this stuff given to you, what's the best like stuff to use to help us set up a proportion here? Okay, so you guys see that there's the hypotenuses on 2 of the triangles and then there's 2 of the smaller sides, right? Okay, so you did 6 over X equals 10 over 6 maybe? And if yours doesn't look exactly like that, As long as the 6's are diagonal and the 10 and the x are diagonal from each other, you should be fine. You just don't want to have the 6 and the 10 be diagonal because that's not going to give you the right numbers when you start cross multiplying. Okay, so if we cross multiply here, we get 10x equals 36. What would you guys do to solve this one? Good, divide by 10, what do you get? 3.6. Okay, we didn't get a whole number that time. Sometimes you're not going to get a whole number. Sometimes you're not even going to be able to do something with a square root. Okay, but that doesn't mean that you did it wrong. It just means that maybe this one doesn't work out as nicely as some of those other ones did, right? Okay, we've got one more here on this page, and I will just kind of say this last one is a little bit different than the other two. It's going to be a little more challenging. So let's start by sketching out our 3 triangles. Okay. Let's take a look at the small triangle. What can we label? You guys tell me where I should put my stuff at. Okay, 3 here. Okay, good, 9. I think that's all we got for the little triangle, right? How about the middle, medium-sized one? Yeah, all we can say is the hypotenuse would be y, okay? How about the big triangle? Okay, good. You know the bottom is 9, and you know that other longer side is y. We don't know anything about the hypotenuse. We don't have enough to say anything about it, right? Okay, so if we look at this, is there like a clear way to set up a proportion right now based on what we have? No, not really. I mean, there's some pieces that maybe look like they have a partner, like the bottom 3 and this bottom 9 can go together. This 9 and this y can go together, but those are all on different triangles as far as I'm trying to match them up. So in the past, we've talked about something called Pythagorean's theorem. We might need to use that to help us get this problem started. So if I look at this small triangle here, remember a squared plus b squared equals c squared? Do you guys remember what numbers would go where? Good. I like it. Okay. So if you square these, what do you get? Good. If you subtract the 9? Good, 72. Now, I can't square root 72, but we've spent some time working with square roots, right? What's the biggest perfect square that goes into 72? Good, 36. 36 times 2, so this would become what? Good, 6 square root of 2. And so that would be this side here. All right. Now, we're not done. Okay. We haven't even done a proportion yet. But we had to find that in order to make a connection from the little triangle to maybe the big one. Because that middle-sized one, again, yes, we have a y. It's not really going to help me, though, because I don't know either of the other two sides. So I can't use that triangle for my proportion at all. So let's try to figure out a way to set up the little triangle to the big triangle. What could you guys put together? Okay, I'm just going to underline those things that you're saying go together. So the 6 square root of 2 and the 3. Let's go ahead and just set that 6 square root of 2 over 3. What would that equal on the big triangle? Good, y over 9. So now if we cross multiply, we get 3y. Remember, you can take the 6 times the 9 because those are outside of the square root sign. So that's 54 square root of 2. And then how would you guys get y by itself? Good, you would divide by 3, and to do that over here, the only thing you can divide by 3 is the 54. You can't do it with the 2, because remember the 2 is underneath the square root sign. So 54 divided by 3 would be 18, and then that square root of 2 has to stay. Okay, so like I said before we even began, this one was a little bit different and more challenging than maybe those other two that we did. And that's because one, it maybe wasn't as obvious to see what they had in common, and we had to use Pythagorean's theorem to help us out, which we haven't talked exclusively about yet. We've kind of seen it pop up here and there throughout this class. We're going to be talking more about it in the future. but that was one way to get us started here so that we could then get to our proportion. But I would say this one, it maybe wasn't as obvious as these ones up here where like you saw for sure, like the Y's were repeated, the sixes were repeated. You didn't see that on this one because of those radicals that were in there. So at the very beginning of the lesson, I kind of talked about that the numbers won't always be what you're maybe expecting them to be when you're setting up these proportions, but they still are going to work out the same way. All right. Does anyone have questions on this? Okay, we're going to get you guys the homework so you can practice doing geometric mean.